You know that feeling when you're just writing code, but you really want to be architecting systems? Well, that's exactly the leap we're going to talk about today. We're diving into a really powerful concept called the builder pattern, and it's all about one simple idea: separating the plan for something from the thing itself. It's a huge shift in thinking, and it all starts with a problem I think we've all faced.
Yeah, we've all been there, right? Meet Timothy. He is absolutely wrestling with his code. It's become this tangled web where one tiny change to, say, a database setting kicks off this frantic search and replace mission across his entire project. And this isn't just annoying, it's super fragile. It's a huge warning sign that there's a deeper design problem at play.
So, Timothy's pain? It actually has a name. His mentor, a seasoned architect named Margaret, calls it the construction site problem. And really getting what that means, well, that's the first step to building software that's way more robust and, honestly, just more elegant.
And this right here is Margaret's diagnosis. It's brilliant. See, Timothy was trying to pass around and copy a live, active database connection. She pointed out that he was basically trying to move an entire finished house from one place to another, when all he really needed to do was share a copy of the blueprints. It's clumsy, it's inefficient, and most of the time, it just breaks everything. The real power, the real flexibility is in the plans.
Okay, so this brings us to the core idea that makes the builder pattern so easy to get. Once you truly understand the difference between the blueprint and the actual house, everything else just clicks right into place. So let's define a term you'll hear a lot: a heavy object. What is that? Well, in programming, it's anything that's tied to an external resource. Think about a live database connection. It's not just a bunch of data, it's an active, open channel to a server somewhere. Trying to copy that is like trying to photocopy a running car engine. It just doesn't work. You're going to get a mess.
And here's the solution, laid out perfectly. On one side, you've got the house. That's your heavy, live connection. It's the finished product, the action. It's complex, and you absolutely cannot copy it safely. But on the other side, you've got the blueprint. And what is that? It's just the intent. It's a lightweight set of instructions, the host name, the username, maybe a port number. It's just data. You can copy it, pass it around, store it. You can make 1,000 copies and it causes zero problems.
All right, enough with the metaphors. Let's get our hands dirty and look at some actual code. How do we build one of these blueprints in Python? You're going to see it's surprisingly simple.
So, first up, we create our database blueprint class. Now look closely at this _init method. Pay attention to what it's not doing. See? It's not connecting to anything. It's not creating any heavy objects. All it's doing is gathering up the configuration details, the host and the user, and storing them. This little dictionary right here is the blueprint. It's the lightweight, safe-to-copy intent to connect later.
And here's part 2, the magic, the .build method. This is the action. When we decide we need a connection, we call .build. It takes that config we stored earlier and uses it to create a brand new, live, heavy connection right on the spot. This is the moment the house actually gets built from those plans.
Oh, and a quick but super important pro tip here. Did you notice how the password isn't just typed into the code? It's loaded securely from something called an environment variable. This is absolutely critical for security. It keeps your secret credentials out of your code, out of your Git history, and away from prying eyes. This is what professional code looks like.
Now let's put it all together. We create our blueprint just one time, and we can hang on to it. Then anytime we actually need a connection, we just call .build. You need another one? Call .build again. Each call gives us a completely fresh, independent, and safe connection. No more weird copying errors, no more mess. Just clean, reliable connections on demand.
You see, this isn't just some clever coding trick. Adopting the builder pattern is a fundamental shift in how you think about designing systems. It's about moving from just making things work to making things work in a way that's scalable, maintainable, and robust. And Margaret's wisdom here just nails it. As your systems get bigger and more complex, trying to manage all the live, heavy objects becomes an impossible task. The real power, the thing that lets you scale, is holding on to the knowledge of how to create them whenever you need them. So if you remember one thing, let it be this. By using the builder pattern, you create this beautiful, clean separation between the config, which is your intent, and the connection, which is the final action. That separation is the secret sauce for writing flexible and powerful code.
All right, to wrap this all up, let's take a quick look at Margaret's cheat sheet. Think of this as your go-to guide for when you want to use the builder pattern in your own projects.
I mean, just look at the difference here. Before, you had configuration details scattered everywhere. After, it's all in one centralized blueprint. Before, you had programs crashing because you were trying to copy connections. After, you get fresh, safe connections whenever you want. And you go from huge security risks to handling credentials the right, secure way. The benefits are just massive.
And hey, don't for a second think this is just for databases. This pattern is so incredibly useful. You can use it for API clients, for network sockets, for file handles, heck, even for loading gigantic machine learning models. Basically, any heavy object that's expensive or risky to copy is a perfect candidate for a blueprint.
So, I'll leave you with this question. Take a hard look at your own code, at the projects you're working on. Where are you trying to move the whole house when all you really need is to pass around a simple, elegant blueprint? What parts of your system are just waiting for an architect to step in?